Dr. D.Y. Patil, Institute of Engineering, Management Research, Akurdi, Pune. Well, I'm Dr. Anand Tapase, as rightly said by Professor Rohit. He is one of my best good friend in Pune. Well, I have been alerted with the topic of design of pavement. Whether I am audible to everyone?
Yes, sir, you're audible. No problem.
Thank you very much. Thank you very much. Well, I have been allocated with the topic of design of pavement. It has a vast detailed things that can be talked about. Also, there can be some introductory part which may not be a good sign. If suppose the uh, participants, if I'll see that there are teachers from various universities and departments, there are a number of research scholars in the PhD, as well as there are young budding engineers. So I have restricted my content to such a way that it won't be an introductory part, it won't be in much details. So I'll be sticking with the topic so that every audience can get a good knowledge about the design part of it. Well, on this completion of this lecture, the participants will be able, well, before that, I should thank the Department of Civil Engineering and Dr. D.Y. Patil Pratishthan's Engineering College. Specifically, my dear friend Dr. Praveen Gorde and Rohit and all the conveners, coordinators of this workshop for giving me this opportunity to be in front of you to deliver this session. Well, on the completion of this particular session, the participants will be able to comprehend the design parameters as per IRC guidelines, and will be get introduced to the pavement design specifically we are restricting our session as we have got just 60 to 90 minutes of time. It will be related to the flexible pavements. Prior to that, there should be some question that in our mind should be raised related to what planning is, why design is required. We have gone through the earlier ages that the roads were constructed in such a manner that even there are some roads which were built in the Rome, either or there are various roads which were constructed in the British era, that still they are in their good conditions. And presently, we should have some questions in our mind that what exactly the planning and designing stages are and what we should restrict ourselves to. There are different types of failures that has been encountered considering the rating and fatigue as such is concerned. Well, I'll be introducing you to the highway and various parameters in just succession in a minutes of in couple of minutes so that we can have an idea about what exactly we are concentrating on. We will be discussing about the pavement design and how we are going to identify the traffic and loading conditions. Well, this is one of the photo that will showcase you the best car in the world, the Ferrari and petrol. Are our Indian roads are made for those cars? This can be a question that should be raised in your mind before planning or designing a pavement. If suppose not for those cars, whether for the overloaded vehicles like this on the Indian roads. Dear Rohit, I am audible properly. I won't be
Yes, sir,
disturbed.
you're audible. No problem. And presentation is also no issue.
Okay, I'll not be disturbing you in between. If suppose there is some, if suppose I may not be audible in between, just you can poke me out. Fine, thank you.
Yeah, yeah, sure, sir, sure, sir.
Well, this is not also the case where the Indian roads are being considered for that. There are certain legal either or the standard axle limits have been set by the Indian Road Congress (IRC). But of course, we are encountering the roads with such overloaded vehicles, and our Indian roads are not been meant for such type of overloaded vehicles also. As I rightly said about, we are not, of course, considering such cars on our Indian roads. We are not considering this type of overloaded vehicles. Then what we are considering? We are considering a mixed traffic in such a manner that there should be the flow of buses, trucks, tractor trippers, there should be small cars. So such type of traffic, a mixed traffic we are considering for Indian highways, and such questions should arise in your mind. Well, moving forward, are we having enough tire pressure in our tires of our vehicles? This is one of the questions. Of course, it is affecting the design paradigm while designing a pavement. Well, how it will be? It will be hazardous in case of designing. We'll discuss later on. This is what I was speaking about. That there are historical roads that even we are getting an example of. There is a 2000 years old road on the Rome. There are many constructions in the British era that were being done. So this is what the historical roads are. Of course, not only going to the many centuries back, coming to the few decades back, that there are major achievements by the Minister of Road Transport and Highways in India also. They have constructed the Golden Quadrilateral around 20-25 odd years back. They have constructed the North, South, East, West corridor also. And there are number of development works that have been carried out under National Highway Authority of India Act that was started or that was enacted in 1988. From that, upgradation or the development of national highways have taken place. There were the number of expressways were constructed, number of bypasses, flyovers were also constructed. This is what we have witnessed. This is what we have witnessed on the Indian conditions on the Indian highways. But exactly speaking, also on the similar line, we have witnessed the failures of the roads in the form of alligator cracks, distresses in the pavement due to fatigue and rutting. There are a number of potholes which we have already seen on number of cases. This is the scenario that due to the weak subgrade, every time such type of rutting parameters are also being considered. Various types of failures in rigid pavement, flexible pavement in different types of roads are being encountered. Pothole formation, bleeding and rutting and patches. We have noticed everywhere on Indian terrain. Around 70 to 80% of patches, failures we have already seen. So what may be the reason? By the common man's perspective, this should be the reason. Well, just corruption, giving bribes. This a common man can think about. Even we as an engineer can also think at on the first priority itself. But whether speaking in right direction, whether this is the only parameter, this may be the parameter somewhere. This may be the parameter. I'm not completely scratching this out. But whether considering the common man's perspective while designing a pavement will be true, whether this cannot be the parameters, can't be the reason for failure of roads. It can be the overloaded vehicles as I was talking about. There may be hot weather. Hot weather. We are conducting tests on various highway materials. Like we are considering the softening point. We are considering the penetration value and various tests we are performing in the laboratories before that material should be used on the road construction. Well, considering the example of softening point, it is having around 45-50 degrees Celsius climate, average climate we can consider of Indian perspective of Rajasthan, like region is around 45 degrees Celsius. From Maharashtra region, we can say it is of 42 degrees Celsius, maximum temperature that has been taking place. So whenever we are using the bitumen, either or tar, or in the road construction, we should have the softening point above the average maximum temperature. That is one of the thing. But uh, due to the hot weather, due to the cycles of climate, due to the heavy rain, and due to the bad subgrid stratas, failure may take place. In the year 2018-2019, we have witnessed a heavy rainfall where in the history of last 4 5 decades, we have not witnessed such type of heavy rainfall. So this may be the conditions. Of course, as far as the common man's perspective is concerned, he may be restricting himself to the condition that is under table, over table. But considering as an engineer, as a highway engineer, or as a transportation engineering expert, we should not neglect those points. That overloaded vehicles are one of the reason for the failure of the roads. There are a number of places where heavy rainfall is deteriorating the roads in number of ways. The hot weather followed with the winter season is also one of the parameters. The nearness of water table can also be one of the parameters. So this will happen regularly. The frequency will increase due to the global warming and other parameters. But should we restrict to the design conditions that were adopted in 50 years back and which we are following right now? After 10 odd years, of course, the design parameter needs to be changes. So Indian Road Congress is always in the mode of changing. They are adding many things. They are deleting unwanted things. So IRC 37 is concentrating on this. What needs to be done? Well, it has a very good history about the IRC 37 is related to the design of flexible payments. There was a code on in 2001, then it was been modified in 2012. Now we are coming to the 2018 IRC code. There are some changes, the little bit changes, but IRC 37 2012 is not been completely absolute. We are still using IRC to 37 2012, and the modification is there. Some other parameters have been added in IRC 37 2018 after 6 years. Well, introducing you to the highways and various parameters is one of the important parameter of this today's session before we will enter into the design of pavements. Well, um from our perspective, the highways are the nearest to the people and give maximum door-to-door services to one and all and has maximum flexibility. Well, this is one of the reason why we love highways. On the same time, on the other time, we should know what exactly the highway engineering are. Highway engineering covers the study, planning, design, construction, and maintenance of roads, along with its required components like bridges, tunnels, grade separators, etc. Well, study, planning, design, construction, and maintenance are the steps that we are following in the construction of or either or having a project dealing with the project of highways. So this is the basic definition of highways and the highway engineering we should know about. We have gone through the every time we are using highways, but are we familiar with the components? Are we familiar with the parameters? Are we familiar with the terminologies related to this? Like what type of road users we are? Are we using the national highways regularly? Are we using the state highways regularly? Are we using the MDR, that is the major district road, other district road, or village road? What type of road we user we are? We should know about it. So, as far as my knowledge is concerned, and after referring number of national and international books, I have come to the conclusion that there are a number of parameters on which the highways are being classified. Not only on the 20-year plans, we should restrict ourselves that the highways are being classified as expressways, national highways, state highways, major district roads, other district road, or village road. There are a number of parameters. For example, considering season and weather as one of the parameter, carriageway is one of the parameter, material used is one of the parameter. Let us take an example of common sense. In village, we are using the all-weather seasonal road. We are using the national highways on various patches are being constructed with bituminous construction, and various constructions are related with the concrete construction. So this is one of the part related to the material. So that is one of the classification that we have to consider about. So there are a number of classifications, parameters, and on that the classification is been divided into around 40 to 50 55 sub classifications have been done. Of course, that is not the part of our today's discussion. Out of complete road classification, we will be discussing in details about flexible payments only. Well, what is flexible payments? Flexible payments are the structures which are deflecting under loading. Flexible enough. They are composed of various layers, and each layer is having a separate properties. In order to get maximum advantage of this property, layers are usually arranged in order of descending load bearing capacity. The highest load bearing capacity will be at the top and the lowest to the bottom of itself. It means that the maximum expensive will be the topmost layer and the minimum will be at the bottom layer expensive. Those are the points that is related to the flexible pavement, that is bituminous roads, tar roads, or asphalt road, one and the same. Well, of course, there are difference in properties of bitumen, tar, and asphalt. We people are bit aware about. More than 80% of roads in Indian parameter as concerned has been constructed with the flexible pavements only. Now the scenario is getting changed. What is design and planning, and what parameters, what components are being focused in planning, and what components are being focused in design? We should be very clear about. We have gone through the term related to the alignment, that deciding the center line of the road. Now, what is road? What is the road structure? What is the pavement? What is the we will just come to that point also, because many confusing terminologies are there, and because of which we are getting focused, like uh, whether pavement is the road, what is the complete pavement, what is the complete road. There are difference in that we will discuss about. So the first thing is, for planning an highway we should plan an alignment, and we are a bit aware about that it should be safe, comfortable, easy and economical. That is the parameters that we should know about the alignment. And about pavement design, it has been divided into two parts. I'm not talking about flexible either or rigid pavement. I'm just talking about the pavement design is been divided into two parts. That is, the first one is the thickness design. That is the point we are going to discuss in detail today. And second one is the mixed design. Mixed design is related with the experimental work that we are carrying out on the Marshall-Sabatini method. And the thickness design is restricted with the guidelines that have been proposed by the Indian Road Congress guidelines. For example, IRC 37 for design of flexible pavement, and IRC 58 for the design of rigid pavements. We have gone through, while teaching, while discussing with the students, we have gone through those figures. Those figures are not been built by myself. It has been taken from Google either or from any of the reference books, as I have restricted my session to have the audience in considering into the mind that there will be professionals from the field, there will be professionals from the academic, as well as there are undergraduate students also. So we will be having a perfect. Trying to bridge the gap between them. Well, the cross-sectional elements can be seen that there is a camber, there is a width of carriageway, curb, whatever the terminologies are there. Well, considering this as the first figure, road details. Starting from the road margin, shoulders, roadway, everything is a part of road details. This is considered as a permanent land width. And in pavement design, what is pavement? I can just let you know here that carriageway, the portion which has been completely black, including the shoulder, is the pavement. पूर्ण जो पार्ट आहे त्यातला फक्त आणि फक्त म्हणजे हा शोल्डर मार्जिन हा सर्व पार्ट सोडून आपण फक्त कॉन्सन्ट्रेट कुठे करतो, तर वी विल बी कॉन्सन्ट्रेटिंग ऑन द कॅरेज वे आयदर ऑर द पेवमेंट. So this pavement consists of this type of structure, that is road structure. It has a crown, it has a camber, there are number of layers, bottom layer, top layer, base layer, sub base layer, formation layer. So we will be focusing here also specifically on the thickness. How much thickness each layer should be is our main component of today's discussion. Well, when we are talking about the pavement width is one of the parameter. The first thing is like land width for single and two lane roads. Single lanes are, we know that we are considering single lane as 3.75 meter. How that particular width have been taken from? We are considering the vehicle width as 2.44 and the other space is as 0.68 and 0.68. So the single lane is considered as 3.75 meter, and the double lane, of course, it will be the multiple of the same. So those are the IRC guidelines which are being given related to the width of the carriageway and the thickness specification for pavements from IRC's perspective. For single lane, it should be 3.75, two lanes, and likewise. And on the same time, the width of formation is also been given. It is, I have taken from the textbook.com. This is one. If suppose you will just surf on the Google, there are you'll just put the name that design of flexible payments or design of pavement. You'll just come with the first two selections. That is, one is by Tom Matthew. He's a professor from IIT Bombay. He have already given his lecture notes. Very beautiful notes are being there. So second thing is related. Second website is related to the textbook. So I have taken the content from the textbooks that I'm just referred for. I'll not go in much details of this figure. Well, there are a number of advantages that flexible payment do have. The initial cost of construction is low. The repair can work can be done smoothly, and number of payments in the Indian perspective are constructed with the flexible payments. And there are a number of disadvantages also. Maintenance cost is relatively high. The lifespan is low. That should be for us. Well, flexible payments do have different layers. Starting from the bottom most, that is the subgrade course, then it is sub base course, it is base course, and there are some layers like DBM, SDBC. Above that, we are considering the bituminous concrete, asphalt concrete. So the layers are different, out of which we are just knowing that the design consideration consider only three types of layers. The topmost layer is the bituminous layer. Next to that is the layer which is being constructed with the muron. In number of cases, the terminology we are using as grade 1, grade 2. In number of cases, we are using the terminology as sub-base, base course. In number of terminologies, we are using the terminologies as WMM, wet mix macadam. We are using WBM, water bound macadam. For subgrade, there are two types of subgrade actually, truly speaking. This is a part of the research that we should focus, the faculty members can work on it. That subgrades, the natural subgrade, to increase the CBR value of that natural subgrade, we should have the artificial subgrade around IRC have proposed a thickness of around 500 above the natural subgrade that should be made artificially so that the CBR value should be increased. So there are in between there are tack codes, prime codes at various intervals. That is not the part of our today's discussion, but that is the part of the construction activity that has been carried out in the while constructing a pavement. Well, coming to this photo, now we will be coming to the conclusion that the portion which is in between these white lines, whether the presentation is clear.
Yes, sir.
Yes, sir.
Presentation is clear.
Okay, fine, thank you. The portion between these white lines and the portion beyond this white line up to the shoulders end is the part of our today's discussion. We are focusing on the pavement design parameter. So what is pavement design? This portion is the pavement and we are supposed to restrict ourselves to this. And the thickness of layers which is below that, underneath to that. As rightly said in my earlier slide, that the thickness design and the pavement design and the mix design are the two different components, out of which the IRC 37 and IRC 58 are the codes which have been proposed by the Indian Road Congress for the design of flexible pavement and the design of rigid pavement respectively. Well, Marshall stability method, even though it is one of the oldest method, but still today it is being used as it is, because it is one of the important tests that is related to the simulation of roads in the laboratory work. Why we should perform the pavement design? Well, earlier in the era of British, they have constructed roads, they have constructed bridges, they have constructed railroads with their premium perspective to transport the goods. Due to their selfishness, they have constructed the roads in Indian conditions. Wherever they were requiring, there were raw material up to that, to reach up to that raw material. They have constructed the roads, they have constructed the transportation routes everywhere. Those days, the quality was only parameter. They were not looking after the economy. They were looking after the thickness, that it should be the thickness. But in today's area, in today's perspective, we are supposed to reach to the areas where, which are in the forest, which we cannot reach, which are beyond our capacity to reach. So there are a number of programs which are being initiated by the state government, by the national government. That is, for example, PMGSY, Pradhan Mantri Gram Sadak Yojana. There is Mukhyamantri Gram Sadak Yojana. So, what is the main intention of those yojanas or the yojanas? The intention is to reach to the population which has been residing in village. which are been residing in the remote areas. If that is the perspective, we should consider economy as one of the best important parameter while designing a pavement. So we can't go with the blind faith that the thickness should keeping more thickness will be okay. That case is absolutely gone. Today we should consider safety should be the it is like the road should be safe, it should be economical. It should avoid distresses of fatigue and rutting. But in couple of sessions, I have used the word fatigue and rutting on number of places. I'll explain you the consider what exactly the fatigue and rutting concepts are. Well, to support and distribute the wheel loads of vehicles, those are the main parameters while designing the pavements. There should not be unevenness and undulations of the surface along the longitudinal profile. So for those reasons, the pavement design is very essential, necessary. Everywhere, everywhere we have gone through this type of phenomena. We witness, with or visualize to save some amount of money, to gain some profit. The truck transport people are making their vehicles overloaded. Of course, their particular vehicles are also getting deteriorated. But because of their negligence, because of their selfish approach, they are making the roads deteriorated, and it has been the public property which is getting hampered. So overloading is one of the parameter for while that has to be considered while designing the pavement. Well, Indian Road Congress have already given certain parameters. The traffic regulations are following it very strictly, but then also on number of places such type of incidents are being visually observed. Contact pressure, the size of contact area depends on the contact pressure. Well, properly inflated, underinflated, and overinflated, it leads to the large tire contact area, small tire contact area, and it is affecting the deterioration. It is one of the reasons for deterioration of the roads. This is the concept. Let us speak in details about the distress in pavement due to fatigue and rutting. Fatigue is nothing but the cracks which are been observed on the top surface of the layer, and it is due to the horizontal tensile strain that has been developed at the bottom of the bituminous layer. And the second parameter is this one, the rutting one. Rutting is been observed due to the weak subgrades, or if suppose while constructing the roads the subgrade is not properly compacted, in that cases the rutting may be observed. So this is what the failures are we have seen in the earlier slide. Now how the pavements are responding to the loading condition. When there is an axial load on the road, the deflection in the top of the bituminous layer has been observed. Due to that, the development of horizontal tensile strain at the bottom of the bituminous layer are taking place. And the third thing is the development of vertical compressive strain at the top of the subgrade. These two are the vital components or vital parameters for designing a flexible pavement. The flexible pavement डिझाईन जे आहे हे जे काही हॉरिझॉन्टल टेन्साइल स्ट्रेन बिट्युमिनस लेयरच्या बॉटमला होतात आणि सबग्रेडच्या टॉपला जे काही वर्टिकल कॉम्प्रेसिव्ह स्ट्रेन डेव्हलप होतात त्यामुळे होतं. So those are the critical parameters. This is one of the slide. We will be coming on this conclusion, but what conclusions we are supposed to draw from the design is this. We are supposed to develop the design charts like this, wherein uh, on the x-axis have shown the traffic in million standard axles, and on the vertical axis it will be pavement thicknesses in mm. So here you can see that granular subbase, granular base, then DBM and BC layer or the SDBC are the layers. There are four layers in the pavement that we are going to design. What this chart indicates that if suppose the traffic intensity is of 2 MSA, and if suppose there is a traffic intensity of 150 MSA, what is the difference in the thickness? We can observe rightly that in case of when there is a low traffic intensity, in that case the thickness of the subbase layer should be 100, but on the same time the thickness of the subbase layer should be 200. Similarly, when coming to the granular base, the thickness should be 250. Here also the thickness can be considered as 250, but the major difference can be observed uh, at the top layers which are being constructed using bituminous mixes. That is the DBM. DBM is nothing but the dense bituminous macadam, which is the second layer, and the top layer is the BC layer, that is the bituminous concrete layer. Here you can observe the thickness. The combined thickness is 20 plus 30 is 50, and in this case the combined thickness is 50 plus 100 is 150. So around 3 times the thickness have changed. Because of what? Because of traffic conditions. When I have adapted small traffic conditions like 2 MSA. MSA means million standard axles. What is standard axles? That concept I'll be focusing on later on. Million standard axles. In the million standard axle, the first one is 2 MSA, and the last one is 150 MSA. This is one component that based on the traffic, how the thickness is differing. But on the same time, here I have taken the example of plate 8, and plate 8 from IRC guideline is related to the CBR 150%. I'll show you in the IRC guideline also what exactly the plate 8 is and what is CBR 15% is. Well, we have considered the CBR value, that is California Burying Ratio value of the soil as 15%. The IRC have restricted us that the CBR value while constructing a national highway should be around 5%. Below that, we have to consider the thickness. There are no charts available, but we can develop the charts using the IIT Pave software. It has been rightly mentioned in the IRC 37 code. It is available on Google. You can download the PDF copy of IRC 37 2012, as well as you can download the copy of IRC 37 2018. Well, in 2012 guidelines, this has been given that the CBR value, I have taken the strongest CBR value, that is 15% from the guidelines. So this is what the scenario is. If suppose the CBR value, म्हणजे जमीन जर का मजबूत नसेल, जमीन मजबूत नसेल तर नक्कीच काय होणार आहे, ह्या थिकनेसेस अजून वाढणार आहेत. त्यामुळे जशी सीबीआर व्हॅल्यू जास्ती आहे तशी ह्या कंडिशन्स पॅरामीटर, म्हणजे आपण ह्या चार्ट मध्ये आपण दोन महत्वाच्या गोष्टी पाहिल्या. एक म्हणजे ट्रॅफिक जर का कमी असेल किंवा जास्ती असेल त्याचा इफेक्ट थिकनेस वरती काय होतो, आणि सीबीआर व्हॅल्यू जर का कमी असेल जास्ती असेल त्याचा थिकनेस वरती काय परिणाम होतो. There are two design procedures adapted till today. There are subdivisions of those methods also. Empirical design method, and the second one is the mechanistic empirical design methods. In the empirical design method and the mechanistic empirical, we'll see the difference about this. The empirical design method is based on the experimentation and experience. Let me know if suppose we have adopted something that have been considered in America. We have taken number of things in our IRC guidelines which have directly coming from British either or American codes. ASTO guidelines we have taken, we have considered British guidelines, we have gone through the Australian guidelines, and there are a number of things in our Indian Road Congress guidelines that are resembling or that are being taken from the experiences that have observed in those continents, in those countries. If that experience we are going to see in our case, wherein we do have various different geological conditions, there are climatic factors are different, we do have a terrain classification, the parent rock varies from state to state, from province to province. So how we can rely on such type of experiences that those people have observed in their continents? This is the empirical approach that we have followed while designing the pavement. There are examples of design without soil, means there should be soil conditions, soil test should be done. There are something that they have observed in their continents and they are following it blindly. that were happening, but it have taken place by the mechanistic empirical design methods, wherein the mechanistic empirical method of design is based on the mechanics of materials that relates inputs such as field loads, outputs, and the responses. We have focused on the critical parameters. In case of rigid pavement, there are three parameters. In case of flexible pavement, there are two parameters. In rigid pavements, we are concentrating on the stress parameters, that is on the corner, on the edge, or at the center. And in case of flexible pavement, we are focusing our attention to like only two parameters, two critical parameters, and that is to the strengths. That is the horizontal tensile strength and the vertical compressive strength. रटिंग होण्यासाठी माती जर का कमकुवत असेल तर रटिंग होतो, म्हणजे अंडुलेशन्स आपल्याला दिसतात. आणि फटिक जे आहे म्हणजे आपल्या वरच्या टॉप लेअरवरती जे काही क्रॅक्स दिसतात, ते क्रॅकचं मेन कारण आहे फटिक. फटिक जे आहे याचं मेन कारण आहे की डांबराची जे काही मिक्स आहे त्याच्या खालती जर का हॉरिझॉन्टल टेन्साइल स्ट्रेंथ अलाउएबल लिमिटच्या जास्ती झाला तर तिथे आपल्याला तिथे काय होतं तर फटिक दिसतो. तर मेकॅनिस्टिक इम्पेरिकल डिझाईनची जी काही फिलॉसॉफी आहे, ही फिलॉसॉफी अशी सांगते की तुम्ही जे काही इनपुट्स टाकचाल त्याच इनपुट्सवरनं तुम्हाला आउटपुट्स मिळणार. असं नाहीये की तुम्ही अमेरिकेमध्ये काहीतरी करताय आणि त्याच्यामध्ये त्यांना फेल्युअर दिसलं, त्यांना काहीतरी चांगलं दिसलं. तर मी एका कामावरती मी एक काम केलं होतं, त्याचे रिझल्ट्स मी टेक्सासमध्ये एक 4.5 कोटी रुपयाचा रोड होता. त्या केसमध्ये आम्ही ब्लॅक कॉटन सॉइल होती, त्याच्यामध्ये बरंचसं काहीतरी प्रॉब्लेम्स होते. तिथली कंडिशन पाहिल्यानंतर असं लक्षात आलं की त्या टेक्सासच्या त्या ठिकाणी बरंचसं सेटलमेंटचे प्रॉब्लेम्स होत आहेत. मग तिथे आम्ही थोडेसे ऍडमिक्सर्स वापरले, तिथे आम्ही काही बाकीच्या अजून काही गोष्टी वापरल्या, त्या अजून थोड्याशा अजून चालू आहेत आमच्या. ती गोष्ट इथे होईल असं नाहीये. आपल्या इथली थिकनेसेस वेगळे आहेत. वी डू हॅव completely different geographical features. So we can't rely on the things which were based on the experience of the other continent, other countries people. It should be from that. And also every time it is not possible that construct a road and see the what it आपल्याला काय रिझल्ट मिळतात असं होऊ शकत नाही. त्यामुळे आपल्याला काहीतरी त्याचं सिम्युलेशन करणं गरजेचं आहे आणि त्यासाठी आपल्याला हे डिझाईनचे जे काही कॉन्सेप्ट आहेत ह्याला थोडंसं एक मेकॅनिक्स्टिक इम्पेरिकल डिझाईन पॅरामीटर जे आहेत ह्याला आपल्याला काय करावं लागेल तर आपल्याला IIT पेव, केन लेअर किंवा असे बरेचसे असे सॉफ्टवेअर्स अवेलेबल आहेत, अशा डिझाईन प्रोसिजर्स अवेलेबल आहेत, त्याच्यामध्ये आपल्याला ह्या गोष्टी वापरणं गरजेचं आहे. उदाहरण घ्यायचं झालं तर ऍक्सल लोड्स, मी पुढे त्या कॉन्सेप्टवरती येतोय सर. ऍक्सल लोड्स वेगळे असतात, म्हणजे लोडिंग समजा आपण आता मगाशी ओव्हरलोडेड व्हेकल, हा मी एकदा नाही तर 2 वेळा तुम्हाला ते ओव्हरलोडेड व्हेकलचे स्लाइड्स दाखवल्या. त्यानंतर मी तुम्हाला हे दाखवलं की क्लायमेटमध्ये व्हेरिएशन्स होत आहे. त्यानंतर मी तुम्हाला हे दाखवण्याचा प्रयत्न केला की पाण्याचाही इफेक्ट होतोय बऱ्याचसा. तर आपण CBR 15% धरलं, 15% धरलं म्हणजे सर्वात चांगली CBR आहे. आता इथं मी सातारा जिल्ह्यामध्ये राहतो, तर आम्ही माझ्याकडे दोघं जण PhD करत होते, तर त्यामध्ये आम्ही पाहिलं सातारा कराड इथल्या ह्याच्यामध्ये पाहिलं मी की बऱ्याच ठिकाणी CBR 2%, 3% अशी कमी येते. काय करायचं अशा केसमध्ये? व्हॉट नीड्स टू बी डन? सो इन दॅट केस we have proposed some charts from the outcome that we have got from IIT PEV and that have म्हणजे जे काही आम्ही केलं ते आम्ही स्प्रिंजर, अमेरिकन सोसायटी किंवा ASTM अशा ठिकाणी पाठवलं आणि ते वर्क आमचं त्यांनी थोडंसं रिव्हिजन सांगितलं. त्या पद्धतीने आम्ही परत साईटवरती गेलो, परत एकदा एक्सपेरिमेंटेशन केलं, परत त्याचं अनालिसिस केलं आणि आम्हाला जे काही रिझल्ट मिळाले, तर उदाहरण घ्यायचं झालं हे वरती जे काही मी तुम्हाला चार्ट दाखवले, हा जो चार्ट आहे, रोहित चार्ट दिसतो आपला?
Yes, sir. Yes, sir. No problem.
तर हा जो चार्ट आहे, असे चार्ट्स आम्ही प्रपोज केले. आता स्पेसिफिकली IRC काय करतंय, तर IRC आपल्याला या स्पेसिफिक CBR व्हॅल्यूसाठी चार्ट रेडीमेड देतं. आपण आता जे काही डिझाईन प्रोसिजर पाहतो आहोत, जे मुलांना शिकवायची आपल्याला, तर ती आपल्याला रेडीमेड अवेलेबल आहे की बाबा ही अशा व्हॅल्यू मी तुम्हाला ही दाखवतोय पुढे. पण जर का एखादा खरंच रिअलिस्टिक प्रॉब्लेम आपल्याला सॉल्व्ह करायचा आहे, जो की मी बऱ्याच मागच्या 12-15 वर्ष झालं त्याच्यावरतीच काम करतोय, तर हे असे डिझाईन चार्ट्स आपल्याला प्रपोज करता आलं पाहिजे. हे आपलं एमटेकचं PhDचं वर्क असू शकतं आणि हे माझ्याकडे आता अजून 1-2 कॅन्डिडेट्स काम करतायत. तर त्यामध्ये आम्ही असेच डिझाईन चार्ट्स म्हणजे आता तुम्ही पुण्यामध्ये आहात तर पुण्यामधलं एक स्पेसिफिक लोकॅलिटी घेतली, पिंपरी चिंचवड घेतलं किंवा तुमचा आकुर्डी एरिया घेतला, तोही एरिया घेतला आणि त्याच्यामध्ये तुम्ही रिगरस एक्सपेरिमेंटेशन वर्क केलं, आपल्याला पॅरेंट रॉक माहित असतो काय आहे. मग त्या केसमध्ये आपण जर का ते घेऊन आपण केलं तर असे डिझाईन चार्ट्स आपण प्रपोज केले, दॅट कॅन बी अन आउटकम ऑफ युअर वर्क. वेल, आपल्याला रिस्पॉन्सेस पाहायचे असतात. We should focus our attention on the responses. That is, what type of stresses are developed, what type of strains are developed, what is the deflection taken place here. So in case of flexible pavement, we will be restricting to the strains and the deflection parameters. Well, rightly said, we are adopting the mixed type of traffic. We are not only focusing on any particular type of traffic. Thickness of pavement is governed by single load and number of load repetition is not considered. The heaviest wheel load anticipated is used for design purpose. This is the oldest method and is rarely used today for pavement design. This is a fixed traffic concept. What we are using is the fixed vehicles. If the axle load is not a standard one, then it must be converted to an equivalent axle load by number of repetitions of given axle. Okay, हे जाऊ दे. एक नवीन शर्ट घेतला तुम्ही विकत आणि त्याचबरोबर दुसरा एक शर्ट घेतला विकत. मराठी सगळ्यांना कळू शकतं रोहित सर? का इंग्लिशला राहू देईल? मिक्स असले चालेल?
I think no problem.
ओके. लेट अस एक एक्झाम्पल देऊ फक्त. एक दोन
Yeah,
शर्ट
sure, sure.
दोन शर्ट्स घेतले तुम्ही. आज तुम्ही दिवाळीला दोन शर्ट घेतलेत आणि एक शर्ट तुम्ही कपाटामध्येच ठेवलेला आहे आणि एक शर्ट तुम्ही दररोजच घालताय. 2 महिने झाले दोन्ही शर्टला. त्यानंतर आपल्या लक्षात येतं की 2 महिन्यानंतर एक शर्ट पूर्णपणे थोडासा जुना झाला आणि दुसरा जो शर्ट जसा आहे तसाच आहे. टाइम ड्युरेशन भरपूर गेले. 2 महिन्याच्या 60 दिवसाचे झाले. 60 डेज मध्ये गेलेले आहेत. पण 60 डेज मध्ये तुम्ही एकच शर्ट जास्ती वेळा वापरलेला आहे. त्यामुळे त्याचं डिटरेशन, त्याचं जे काही टेक्स्चर, त्याच्या लॉसेस जे आहेत ते दिसतंय आपल्याला की त्याच्यामध्ये लॉसेस झालेले आहेत. हेच पॅरामीटर आपल्याला रोडमध्ये लक्षात आलं पाहिजे की जर का ट्रॅफिक भरपूर त्या रोडवरनं जातंय तर ते 15 वर्ष टिकणार नाहीये रोड. 15 वर्ष हे स्पॅन ठेवलेलं आहे. 15 वर्ष कसं ठरलेलं आहे किंवा 10 वर्ष हा कसा ठरलेला आहे स्पॅन जो आहे, तर हा स्पॅन पूर्णपणे त्याच्यावरून ते ऍक्सल, स्टँडर्ड ऍक्सल किती वेळा जातंय. समजा फ्रिक्वेन्सी जास्तीत जास्त स्टँडर्ड ऍक्सल जातात तर त्या केसमध्ये तो रोड लवकर खराब होणार आहे. तर फिक्स व्हेकलची कॉन्सेप्ट आपण आता सध्या वापरत आहोत. दॅट इज द इक्वलंट सिंगल व्हील लोड. Here the concept can be seen. That is how the stresses are developed, what is the wheel load. Okay. For Indian conditions and the overall world, in the overall other parts of the world, they are considering 80 kilonewton as the standard axle load. What 80 kilonewton stands for? 80 kilonewton is for the complete axle. And while designing the pavement, we are considering one part of the axle, that is the one part where the tires, maybe two tires either or single tire. If I am considering 80 kilonewton, then on one part it will be 40 and on the other part it will be 40. If suppose the assembly is like this, like this, that on an axle there will be two axles, this will be two axles, two tires. So those two tires collaboratively will be having 40 kilonewtons. So on each tire it will be 20 kilonewtons. Fine. Now see, legal axles and the standard axles. In Indian perspective, the legal axle is 102 kilonewton and the standard axle is 81.06 kilonewton. The historical development I have already told about, that in IRC 37 it has started a long way from last 4 decades. 2001 was a milestone revision in the IRC 37 guidelines. Then there was a revision in IRC 37 in 2012. The scope of the guidelines are restricted to the use of granular base and subbase, cementitious base and subbase, cementitious bases and subbases. Variety of research have been taken place all over the various parts of the country. There are in the meeting of Indian Road Congress.
Hello. I think there is a technical difficulty.
No, just am I audible?
Yes, sir, you're audible, but presentation is not visible.
Yes, yes. Please wait for.
Yeah, sure.
Is it okay?
Yes, sir, presentation is visible. No issue.
Thank you very much. The scope of the guidelines are means based on the research which has been taking place world over in the various parts of the country. Every time after the frequency of meeting of Indian Road Congress committee is taking place, in every meeting they do have a sharing about the various research parameters and what they have, different type of research they have added, not added. So likewise, after whenever there will be revision in the codes, they are considering those research work that have been carried out. The use of samilier, the use of reclaimed asphalt pavements are also been added especially. It has been noticed that the design life is considered as 15 years for national highways and state highways I was talking about, but the design life is not in the terms of the duration. The design life is based on how much the standard axle is using that road as such. If suppose the defined parameter is taking place in just 5 6 years, then of course that life of the pavement is over. But as a common sense, we can use 15 years, 10 to 15 years as the life of the pavement. For the expressway, it is taken as 20 years. Now you might have been gone through that. There are certain provisions related to the construction of. There are some addition as well as there are some reparation work that has been carried out on the express highways from Pune to Mumbai that have consumed the life of 20 years. There is one tunnel is there are two twin tunnels is being constructed in the Khambataki Ghat section. So it is related to the years and the duration that the life of the that particular project is. Well, this chart is for 8 CBR, and this 8 CBR we can see again. I am taking from 2 MSA to the 150 MSA. There won't be change in the traffic in million standards. The change is for CBR 8%. When it is CBR 8%, the pavement thickness will vary. This is how the pavement section and the loading details can be seen, noticed. Here you can see 40.80 kilonewton. In Indian condition, it is 81.60 kilonewton is the standard axle, and half of it is 40.80 kilonewton. That is taken for designing a pavement or analyzing a pavement. The topmost layer is the bituminous layer, concrete layer or the wearing course. The second one is the DBM and the binder course. WBM, WMM, then sub base course and the subgrade. So these are the various thicknesses, and for here on the second on this part you can see 100 mm to 250 mm should be the thickness of the bituminous layer. This complete both the layers are considered as one as the bituminous layers, wherein the topmost part is considered as BC AC wearing course or the surface course, and the next to that the second layer is DBM or the binder course. Combination of these has to be in between 100 mm to 250 mm as per the guidelines are concerned. But when we are following the research, don't rely directly on the guidelines, don't rely on the values that are given in the guidelines. It should be like what research means for us. Research means out of box thinking related to a particular topic. If suppose you will restrict, you will draw a constraint, you will draw a boundaries that to the frames of the IRC guidelines. It means that you are follow your we have adopted that IRC guidelines are all correct and everything is up to the mark, and you what the research you are doing is in the within the boundaries of the IRC. If suppose you think out of the box for the particular local situation, local phenomena, where local parameter as such, which you are observing since last many decades, that should be considered as your parameter. If there is a nearness of water table, you should consider that as the design parameter, not to the things that are being given only in the guideline. Of course, guidelines have given some skeleton for working. If suppose blindly we have to follow only the guidelines, it means that everything is up to the mark and the deterioration is only been occurring due to the manual errors. That is also one of the point. Again, I am showing this pavement response figure because like the purple color arrows are important for us. The horizontal tensile strength is the reason for fatigue and the vertical compressive strength is the reason for rotting. Our design of flexible pavement is based on the CBR value of soil. Two charts I have shown you. One is for 15% and one is for 8%. That are ready-made available on the in the guidelines. So I have taken some screenshots from the guidelines directly for sake of convenience. Well, pavement design catalogs. Pavement design catalogs are based on these five terminologies. The first one, that is the figure 10.1, is showcasing the granular base and granular surface. I'm not showing you any rocket science. It has been available in IRC 37 guidelines, which is been available free of cost on your Google search engine. Just go on, just type IRC 37 2012. You'll get the PDF from various sources. Well, pavement design catalog. Just I'm pointing out the first figure, that is what layers they have taken, that can be seen. There are altogether 1, 2, 3, 4 layers they have considered. Here you can recognize what I was talking about, that the bituminous layer is considered as single, one layer. The two wheels are considered. Researchers can consider a single wheel, a combination of two. We can consider two wheels as per the IIT PO is concerned. These are the properties of bituminous mixes proposed by IRC 37. Means what we should, there are two major properties, three major properties that should be the input parameters. The first one, how much load you are applying. The standard load, I am talking about 80 kilonewton. 80 kilonewton हा जगातल्या ऑलमोस्ट सगळ्या कंट्रीज मध्ये फॉलो केला जातो आणि भारतामध्ये 81.60 किलोन्यूटन. 80 किलोन्यूटन जरी आपण धरला तरी चालेल. हा स्टँडर्ड ऍक्सेल लोड आहे. हा पहिला पॅरामीटर झाला. पण रिसर्चर्सनी असं नाही केलं पाहिजे. रिसर्चर्सनी काय केलं पाहिजे, मे बी ओव्हरलोडिंग व्हेकल हा डबल होऊ शकतो ऍक्सेल लोडच्या, ट्रिपल होऊ शकतो. तर ज्यावेळेस आपण पेमेंट मध्ये काम करतो आहोत, डिझाईन मध्ये काम करतो आहोत, अनालिसिस मध्ये काम करतो आहोत, तो आपण त्यामध्ये व्हेरिएशन करणं गरजेचं आहे. व्हेरिएशन केल्यानंतर आता उदाहरण घ्यायचं झालं तर कारचं एक्झाम्पल घेतलं तर त्याचे जेवढं काय लोड किंवा त्याचे जे काय स्ट्रेसची फिगर मी दाखवली मध्ये, त्या स्ट्रेसेसचा जेवढा इफेक्ट होत नाही तेवढा इफेक्ट हा जास्ती मोठ्या व्हेकलचा होतो. त्यामुळे मोठ्या व्हेकलचं ऍक्सेल आपण धरलं जातं, त्याला स्टँडर्ड ऍक्सेल धरलं जातं. So that is one of the input. Loading is one of the input, and second one is the input related to the material properties. Material properties there are two inputs in material properties. One is the Young's modulus or the resilient modulus, and second one is the Poisson's ratio. So these two parameters has to be given while you are going through the design procedures. Temperature dependency around in Maharashtra condition, in Pune either or in Satara, we can adopt 35 degrees Celsius as the mean temperature, and VJ10, VJ30, VJ40 grade of bitumens are been more frequently used. Likely say 60-70 grade of bitumen is VJ30, 80-100 grade of bitumen is VJ10. So this type of bitumen mixes can be seen, and the properties, that is at 35 degrees Celsius it is 1000, for VJ30 it is 1700. So we have to rely on this. So this is they have given, unless and until you are having a good experimentation work carried out at your end, you can, instead of going for that expensive work, the values are being well adopted. There are a number of trials errors have been taken, so they have come to these conclusions. Now even the code have included the specification related to the modification of bitumen, that is use of plastic, use of rubber in bitumen. It has been standardized. It was the era last two couple of decades we have worked on the use of plastic in the road construction, use of rubber in the road construction. Now the Indian Road Congress have realized that many of the researchers have gone through this work rigorously, and they have found out that the bitumen is getting exhausted. The natural aggregates are getting exhausted. So there are a number of alternatives partially that can be added as a source of bituminous mixes. So the fourth row you can see BC and DBM for modified bitumen. So they have included the parameters related to modified bitumen also. So those properties can be taken out. Now let us come to the final part of our presentation, that is the computation of design traffic as per IRC 37. This is the formula for cumulative number of standard axles to be catered for in the design in terms of MSA. दोन वेळा मी तुम्हाला चार्ट दाखवला, 2 MSA आणि 150 MSA. तर हा 2 MSA आला कुठून आणि तो 150 MSA आला कुठून, तर त्यासाठी हा फॉर्म्युला आहे. फॉर दॅट cumulative number of standard axles to be catered for in the design in the terms of MSA. So we are supposed to work on this formula to carry out the design traffic. In the annexure of IRC 37, you can just go through this in the IRC 37 guideline, that they have worked on an example that bituminous pavement with untreated granular layer. Example is like, design the pavement for construction of a new flexible pavement with the following data. They have given the data that 4-lane divided carriageway, initial traffic in the year of completion of construction, percentage of single, tandem and tandem axle as are 40%, 45%. Design life has to be considered as 20 years. Then vehicle damage factor, everything has been given. We are lane distribution factor, they have already given. Then initial traffic, vehicle damage factor, that the input data has been given from their side. When we are giving an example to our students, so you can use this annexure 2 as a ready-made tailor-made problem solving method. Here you can see the CBR value of the embankment material is 3%. If the design value is 3%, what will happen? If suppose it is 3%, the thickness will be more compared to that of the regular pavements. Just go through the IRC guidelines, you'll realize that thickness of pavement at 150 MSA for 6% CBR, and the thickness of pavement for the 150 MSA traffic itself will be different for CBR of 15%. जेवढी ताकदवर, जेवढी चांगली, जेवढी स्ट्रॉंग सबग्रेड असेल तेवढी कमी थिकनेस लागणार आहे, जेवढी वीक सबग्रेड असेल तेवढी थिकनेस जास्ती असणार आहे. हे ह्या गाईडलाईनचं महत्व आहे, इथे आपल्याला दिसतंय. So thickness of proposed bituminous layer with VJ40 bitumen with bottom DBM layer having void, means everything has been clearly mentioned in the guideline. This is the formula. The same problem I have taken here. So N, for example, N, if suppose it is 73.02 MSA, what should be the conclusion drawn? So as per the plate 6, as per the plate 8, as per the CBR value, the thickness of the pavement can be chalked out. Here you can see. Let us see here. Our result was N is 73. So for 73, the specific thickness is not been given. So 50 is known, 100 is known, traffic in MSA. So a mean of these both can be taken for considering the pavement. can see the total thickness required is 200 plus 250 plus 150 plus 50. So the higher side is been taken considered. This one. Granular base will be 200, WMM will be 250, DBM will be 115, and BC will be 50. So based on this formula, if suppose it is 150, from this formula, from annexure 2 of IRC, the N value is 131. The N value is 131. So you can see that if it is 131, just go through on the chart. If it is 131, consider for the 150 part of it. So this is the mechanistic empirical analysis. It is the science of motion and actions of forces of bodies. Well, it has been clearly mentioned. Empirical method have been got obsolete because of as we cannot rely on the experiences of the other continent people, and we can't construct every time, and we should not wait for the failure of the pavement to happen in our parts based on the construction based on the experiences of other people. But it is on the same time it is not possible that we will construct every time the way our pavements, and we will see what exactly the results will happen. So for that reason IRC have given the trial error provision in its design procedure, as well as there are some tools like IIT Pave that can be accommodated, that is accommodating a large number of values. IIT Pave software is freely available with the IRC 37 guidelines. If suppose you'll go for the purchase of IRC guidelines from the Indian Road Congress, they will provide you a CD, and the IRC IIT PO guidelines will be freely available to you. For example, if in Satara district there are 11 talukas, and in 11 talukas, you people might be aware about Mahabaleshwar. There is an laterite soil, there is a red soil. There are some places in Koregaon, Pusegaon, they do have a black cotton soil. So whether I should construct a road on in Koregaon, Pusegaon, whether I should construct a road on in Mahabaleshwar, before constructing the road, I can check its property in the IIT PAVE as per the design guidelines. I can check how much thickness of layer should be there in Mahabaleshwar, and how much thickness of layer should be there in place where it has a black cotton soil. So soil parameters like its value of Young's modulus, Breslin modulus, Poisson's ratio. If suppose you do have properties with you, you can directly put that as an input in the software, and you can take the outputs related to the thickness of pavement. So the outputs can be in the form of stress, strain, and deflection. Failure criteria. So from our, I think we are 10 minutes ahead of our regular time, but I have concluded from my side. From this session, we are now able to comprehend the historical development in highway engineering and got introduced to the design of flexible pavement and its basic concept. Also, the importance of mechanistic empirical design. Well, mechanistic empirical design is not the only tailor-made procedure. We can add, delete number of parameters as per as our convenience in the design procedures. The present condition based on various parameters is discussed, and there should be a rigorous research and development carried out in specifically road engineering. Here we have already highlighted. So the references, of course, go. There is nothing rocket science. There are nothing any special references. Every material is been available free of cost on Indian Road Congress, Central Road Research Institutes. There are a number of lecture notes available from Dr. Tom Matthew and Yoder, Parth Chakraborty. The books are really nice. NPTEL videos are also been available. So that's all from my side. Thank you. Take over.
Thank you, sir.
Rohit, up to you.
Yeah, thank you, sir. It was a very informative session based on the design of the payment. Now, moving further, so participants, if you're having any question, any doubts, you can ask to our today's speaker.
Of course, not only today, if suppose you have gone through these particular guidelines, I have shared my number here. That mobile number is also there. You can contact me anytime. I do my number is also with Professor Rohit sir. So you can contact me anytime whenever you feel. Thank you.
So participant, is there any question? Is there any doubt regarding the today's session? Okay, so I think no one is having any doubt. So moving further to the vote of thanks. So yes, I consider it a great privilege to propose the vote of thanks on the behalf of Dr. D.Y. Patil Institute of Engineering, Management and Research. I would like to express our sincere gratitude for your presence here today. We would like to extend our heartfelt thanks to our guest and speaker, Dr. Anand Tapase sir, who have shared their valuable insight and expertise over there. Sir, your presence has made this gathering an enriching and inspiring experience for all of us. A special word of appreciation goes to the Dr. Praveen Gode sir, head of the Civil Engineering Department, Dr. Atul Kolle sir and Amruta Kulkarni ma'am, working as the FDP coordinator, as well as to our dedicated organization team. Lastly, we thank each and every participant present here. Your presence has made the difference, and we hope that the knowledge and the connection gained today will have positive impact to all of us. So thank you so much to participant. Thank you, sir, for your uh,
Well, Rohit,
good knowledge. Yes, sir.
are we having a screenshot of this? Are we having a screenshot with the participants, or whether you have already taken?
Yeah, I have taken all the presentation screenshot with me.
Okay, okay, sir.
So
Thank you very much.
yeah, I will share you. No problem, sir. Okay, so participant, the today's session feedback link will be provided on our WhatsApp group. Thank you, Tham. Thank you so much. With on note of this, I will conclude that the session is over now. Thank you.